let's finish this as it all started. Together. Hey guys, Mr. Shaw here. We're going to be talking about the second type of second method of solving systems, which is going to be substitution. And using that method, what we'll do is we're actually going to solve them algebraically now instead of graphically. And it's pretty straightforward. We're just going to go ahead and jump right in. So here are the steps. Again, the step one, what you're going to do is you're going to again you'll get a system that'll look like this. Like, I don't know, I'm just going to make one up. 2x plus 3y equals 10. And then the other one will be like y equals 4x plus 3. Something like that. Alright, so what you're going to do is that, again, you're going to want to solve one of the equations for one of the variables. Now, in this case, y is already by itself, so it's not, we don't need to do that. Okay, so again, in this, basically, I provided, by the way, the English translations. I know math is a foreign language sometimes. So again, basically, first step says get x by itself or get y by itself, and that's already done for us. Alright, so step 2 says substitute the expression from step 1 into the other equation and solve for the other variable. Translation, plug in what you get, so this part right here, into the other equation. So I'm going to take, instead of writing y in this case, I'm going to replace it with 4x plus 3. So it would look like this. 2x plus 3 times 4x plus 3 equals 10. Again, all I did was I took this and I replaced it with, I replaced y with the 4x plus 3. Make sure you use parentheses. Then you're gonna, we would work it out. I mean, you know, blah blah blah, distribute, whatever. Let's say that I got x equals 2. All right. So now what you're gonna do for step 3 is you're gonna substitute this value. You're gonna take the 2 and you're gonna plug it back in right here, in for x. So it would equal, so y would equal rather 4 times 2 plus 3. So 4 times 2 is 8, plus 3 equals 11. So then y would equal 11, and then you would have your ordered pair. Okay, so again, your ordered pair would be 2 comma 11, and again, guys, I just made this up. I don't know if it comes out to be 2. I highly doubt it. So again, I'm saying you would want to go back and you'd want to check your solution by plugging it back in. And we'll do that in a couple. I don't want to do it in all of them just because it's kind of time consuming, but I'll at least show you how to do it. So let's go ahead and get into the examples. Alright, so again, step 1, it says that you got to get a variable by itself. You'll notice that there's not a variable by itself. So I'm looking for a variable without coefficients, one that is would be pretty easy for me to basically to get by itself in like one step. So you see here, I've got this positive y, which I think would be real easy to get by itself just by subtracting 3x. So I'll do that, and it'll be y equals negative 3x plus 5. Okay, and again, this is what I'm going to plug in for this y down here. So when I plug it in, again, now I'm going to go ahead and plug it in. So it'll be 2x minus negative 3x plus 5 equals 10. Again, this negative out here is just like a negative 1. We're going to distribute it. So 2x plus 3x minus 5 equals 10. Combine our like terms, it'll be 5x minus 5 equals 10. Add 5. So 5x equals 15. And divide. So x equals 3. And that's the first part. Now again, we know that our answers are x comma y. Again, we can't just stop after x. We got to find the other side. So I'm going to take the x, okay, the 3. I'm going to plug it in right here. So it'll be y equals negative 3 times 3 plus 5. So negative 3 times 3 is negative 9 plus 5. So y equals negative 4. Okay, so there you have it. I found my ordered pair where these lines cross. So 3 comma negative 4. And I'm going to go ahead and I'm going to plug them back in just to make sure they work. So let's start with this one. Again, it'll be 3 times 3 plus negative 4 for the y equals 5. 3 times 3 is 9, minus 4 is 5. Okay, so we're good there. And the second one, so 2 times 3 minus negative 4 equals 5. Oh, I'm sorry, not 5, is 10. I was like, that's not going to work. Okay, equals 10. So 2 times 3 is 6, minus a negative 4 is plus 4. equals 10. All right, so we're good. So this is definitely our answer then. All right, let's move on to the next one. Okay, so again, we're going to solve by substitution. In this case, you see that neither the x nor the y is by itself. So I'm just going to work with this top one. The reason I picked this top one is because they're all divisible by 2. So what I can do is I can try to get this x by itself, and then when I divide by 2, I'll still have even numbers. I know how much you guys hate fractions. So I'm going to get the x by itself this time. So subtract 4y. It'll be 2x equals negative 4y minus 8, divide by 2, x equals negative 2y minus 4. So again, here is what I'm going to take, and I'm going to plug in for my x this time, okay, because again, it's x that equals that. So I'll do 3 times negative 2y minus 4 minus 5y equals negative 23. And then now we just need to solve for y. So distribute negative 6y minus 12 minus 5y equals negative 23. When we go ahead and work this guy out, it'll be negative 11y. Again, combine your like terms. Minus 12 equals negative 23. Add 12. So negative 11y equals negative 11. Divide. So y equals 1. And then we'll take it and plug it back in. So again, I'm going to take this 1 up here. It'll be x equals negative 2 times 1 minus 4. Negative 2 times 1 is negative 2 minus 4. So x equals negative 6. So our ordered pair will be negative 6, comma 1. And I'm not going to plug this one in. I want to go ahead and keep going with the examples. But again, you just want to plug it into both systems, or both equations, to make sure you get out the right answer. All right, 2 more. So in this case, again, it really doesn't matter what you get by itself. But what I'm going to do is I'm going to get y by itself. So I'm going to subtract x from both sides. So it'll be y equals negative x plus 10, and that's what I'm going to plug in. So I'll plug it in for y, because again I got y by itself. So 4x plus 4 times negative x plus 10 equals 40. And go ahead and solve. So 4x minus 4x plus 40 equals 40. Alright, so something's fishy here, okay, if you can't tell. 4x minus 4x is just 0, so that cancels. So I'm left with just 40 equals 40. Well, does 40 equal 40? Well, class, yes it does. Alright, so this is a true statement. When you get a true statement, it is infinitely many solutions. Alright, and though that is going to be a dependent system. Okay, alright, last one. Alright, so here we go. We've got this bananas. This is a bananas problem right here. Okay, so I'm going to go ahead. Right here, I think I want to get rid of all these guys, all these fractions. So I'm going to multiply by 4. Okay, I'm going to multiply by 4 to get rid of the fractions. So this, again, the 4's cancel here. It'll be 3x. When I multiply here, 4 divided by 2 is 2, so it's going to be plus 2y equals 4 divided by 2 is 2. 2 times 5 is 10. So it'd be, or easier way to do it would be 5 times 4 is 20. 20 divided by 2 is 10. All right. And here I'm going to actually solve this guy for y. So divide by 2. Divide everything by 2. So it'll be y equals, whoops, that was weird. Y equals negative 3 over 2x plus 7 over 2. And let's plug it in. Plug it in for y. So 3x plus 2 times negative 3 over 2x plus 7 over 2 equals 10. Now again, I'm not that mean. Again, you're thinking, man, Mr. Shaw, you are so mean. But I'm not. When you distribute this 2, both these 2's cancel down here. Okay, and the 2's are gone. So it'll be 3x minus 3x plus 7 equals 10. Something's fishy again. 3x minus 3x is just 0. So that I'm left with 7 equals 10. Does 7 equal 10? No, it doesn't. Okay, so this one is no solution. Parallel lines, and it is an inconsistent system. And that was one thing I did not write on the other one. This one should be, you should write same line here. All right, guys, I'm done here. Hey, have a magic day. Take it easy.